Hello and welcome to the course Introduction to Process Simulation. Now in this course we will make you through the detail of Aspen simulations, and in this module we will introduce about the general flowsheet simulation concepts, and also we'll introduce the Aspen Plus features. Now the basic question is, what is simulation? So simulation has a very wide definition. So simulation is defined as imitation of the operation of a real world process or system over time. Now this real world process can be a chemical plant, it can be a aeroplane, it can be a nuclear plant. So simulation is the intimation of the operations of this real world process. Now in more detailed definition of simulation is, it is a process of designing an operational model of a system and conducting experiment with this model for the purpose either of understanding the behavior of the system or evaluating alternative strategies for the development or operation of the system. It has to be able to reproduce selected aspects of the behavior of the system model to an accepted degree of accuracy. So this is more detailed simulation definition applied for a chemical process industries. Now what is the use of a simulation? So process modeling and simulation is used extensively in the design of new process. You know, when you want to produce a new chemical, you want to design the plant. There are many configurations of plants are available. You can go through the feasibility study, you can design the unit operations, you can design the process equipments. So simulation is used for that. It is also considered as a very useful tool in existing processes intensification and optimization. So this is not only used for newly designed process, it can be also used for existing process. So how we can use, what is the benefit of use it in existing process? Increasing the unit operation efficiency, minimization of material and energy losses, and removal of different operational malfunctions are usual reasons for existing process modeling. So these are the main three areas where simulation can be used in an existing process. Now what is flowsheet simulation? Flowsheet simulation actually use of a computer program to quantitatively model the characteristics equation of a chemical process. Now in any chemical process there are some underlying physical relationships like mass and energy balance, equilibrium relationships, rate correlations, right, like reaction and mass and heat transfer. So these are the some relationship. So when you use this relationship to develop a computer program which will predict the actual process is called flowsheet simulation. And it can predict steam flow rates, composition and properties, operating conditions in a flowsheet simulation. Now what is the advantage of flowsheet simulation? One big advantage is it reduces the plant design time. So how? It allows designer to quickly test various plant configuration in his simulator, in his desktop, and from that various design possibilities he will find out which one is most profitable or which one is most effective. It also helps improve current process, answers what if questions, determines optimal process conditions with given constraints, and assists in locating the constraining parts of a process, which normally we call debottlenecking. So these are the advantages of any flowsheet simulation. So Aspen is one of the flowsheet simulator. So let us understand how a general simulation problem looks like. Suppose you have a reactor where feed is coming, some reaction is occurring here, then this stream get cooled in a cooler and then it get flashed in a separator. So vapor generated is recycled back to the reactor and the bottom liquid is taken out as a product. Now the question is, what is the composition of this product? What is the purity of this product? To solve this problem, we need material balance and energy balance across this small flow, small PFD. So now there are basically major two type of approaches to flowsheet simulation. First one is called sequential modular. Here each unit operation block is solved in a certain sequence. This is used to solve a large number of blocks. So you solve this one by one sequentially. That's why this is called sequential modular. The second approach is equation oriented approach. Here all equations are collected and solved simultaneously. For this, a good starting point is necessary to reduce the iteration time. And there is a third approach, which is a combination approach. It uses the sequential modular approach to initialize, get close to a solution, and then use equation oriented approach to solve the flowsheet more precisely. So use the sequential modular approach to get an initial solution, and then EO approach to do optimization and model tuning. So this is the combination approach which is most effective for large flowsheet simulation. Now we'll tell you about the structure of a process simulators. Any process simulators like Aspen, Pro2 are generally constructed in a 3-level hierarchy. So at the top is flowsheet topology. It is both way connected with physical properties model, and again physical properties model connected with unit operation model, and then unit operation model again connected with flowsheet topology. So these three structure interact with each other to find the simulation solutions. So now the task of the flowsheet topology level, the top level, is the sequencing of unit modules, initialization of the flowsheet, identification of the recycle loops and tear streams, and convergence of the overall mass and energy balance of the flowsheet. So when we do during this course, you will understand what does it means. It will be gradually clear to you. Now the second one, that unit operation model level, what are the tasks? Solving of each unit such as heat exchanger, reactors, separators and so on, using input from the flowsheet topology level with a specialized calculation procedure for each unit type, and feedback of outputs from the unit calculation to the flowsheet topology level. So this is the task of the unit operation model level. And then the third level is called physical property model levels, deals with calculations of thermodynamic models for phase equilibrium, calculations of enthalpy, entropy and other temperature dependent properties of components and streams. So it has to be accessed by the unit operation mode as well as the flowsheet topology level. So, these three structure of a process simulator basically interact with each other. They cannot run independently. They continuously interact with other, and with the help of other topology, with the help of other structure, they come out and solve the problems. Now come back to the Aspen simulations. So Aspen is very widely used simulators in chemical industry. Almost all chemical industries, leading chemical industries across globe, use Aspen in their technology department or R&D department or operation department. So Aspen established itself as a leading simulators in chemical industries, and also over the years Aspen has developed so many equations and so many models and physical properties. Now the reliability of simulations and results coming out of Aspen simulations are accepted by the industries across the globe. Now we will discuss quickly what are the steps in Aspen simulation. So these are the major steps. So step 1 is add components. This means you have to add the compounds which will be used in a simulation, like methane, ethane, propane, pentane, like this. Then step 2 is specify property method. So here you have to specify the method like NRTL, Penn Robinson. So there are so many methods in property. So Aspen will calculate the property based on the property method you supplied. Step 3 is run property analysis. And then step 4 is draw the flow sheet in simulation window by selecting from model libraries. Step 5 is specify feed conditions. Step 6 is specify equipment details. And step 7, run the simulation and analyze the results. So these are basically 7 major steps in any Aspen simulations. In our courses, we will explain with example how these steps are performed in Aspen simulators. So as for now, this is all about an introduction of Aspen simulation. Thank you.